Okay, Alhamdulillah Rabbil Alameen. Today also Allah give us another opportunity to live, to do this class after about 5 days lapse. Okay, we always have to be thanking Allah subhanahu wa ta'ala. Since last week and today, many people pass away, and we have not done anything. Allah have to give us chance, and they have done anything to take their life. The time has come, and they must go. Now, ionic and covalent bonding. That is going to be our topic today. We touch on ionic and covalent bonding briefly when we are doing atoms. Okay, atoms, elements. Okay, but according to the syllabus, these they also did the same. So I'm following exactly the 9-to-1 syllabus. They touch on ionic and covalent bonding, and they do it as a separate chapter, detailing ionic covalent bonding, examples of ionic and covalent bonding. Okay, examples of covalent bonding. Where's the black? The syllabus did it exactly the same thing. So we are going to define what is ionic bonding. What is ionic bonding? Okay, we have come across it before. Okay, ionic bonding between group 1 and 2 and group 6, 7, group 6 and 5, 6, 7 non-metals. Yes, we are going to do the examples. Yes, so you see how it's that is going to be done by the what you call the dot and cross. Okay, the dot and cross, CROSS, structure. Okay, and we will be looking at the properties of ionic compound. Properties of ionic compounds. And then we look at the giant ionic compounds like sodium chloride. You call it lattice here. Okay, because sodium chloride is positive and negative. Yes, you have sodium positive and chlorine positive in it. So if it's in a giant big structure, you may have sodium here, chlorine here, sodium here, chlorine here, sodium here. So it's just like a big structure like this. Okay. Okay, sodium. That's why when they dissolve in water, they can conduct electricity because of these ions can function. Yes. Now we're going to be looking at the properties we know. Normally, the chemical properties we're looking at. Okay, and we're looking at electrostatic forces. Okay, electrostatic forces between within an ionic bond. Yes, within an ionic bond. Yes, there are two. One is called intramolecular forces. Molecular forces and intermolecular forces. Inter means within the ion itself. Okay, you have sodium and chlorine. Okay, you look at the outermost cell, chlorine, having 7. Okay, and then you'll be looking at the sodium. Okay, sorry. This is a covalent bond. Yes, sodium ion, I think 8 here, and went positive, and then we have the chlorine ion, now 8 here. Okay, and 1 minus. Okay, this is the This is the molecular structure, how it is depicted, yes? So we are going to look at these forces, and these forces are responsible for high boiling point and low boiling point. In fact, they will explain about the physical and chemical properties of ionic compounds. And then we are going to look at covalent bonding under these same headings, okay? We are going to look at covalent bonding under the same headings and how to draw the structure. Now the structure is examinable. They want you to be able to show how the ionic bonding takes place, okay? They want you to show the arrangement, or what you call the cross and dot diagram, okay? They want you to show the cross and dot structure or diagram. They want you to, examiner want you to show that, you know, and you look at one exam question here, you can see it's there, okay? You look at one exam question. So what is an ionic bonding? Between an example of ionic bonding between group 1, 2, 3, group 1 and 2, which are metals, okay? Then group 5, 6, which are non-metals, yeah? And they are gases. We are going to use the dot and cross diagram or structure to depict this. And then we look at the properties of ionic compounds and the giant compound like sodium chloride and the electrostatic forces. In fact, that will explain why the properties are, why you have high boiling points for ionic compounds and why they dissolve in water. Unlike covalent compound, which can dissolve in water, ionic compound can dissolve in water, then they form their various ions, chlorine and sodium ions, and they can conduct electricity, and they have high boiling point because of electrostatic forces within the molecule itself and between the molecule itself. Within the molecule, it's called intra. Okay, the forces between the negative and the positive, the forces that bind them together, that is called the intramolecular forces within the molecule, because sodium and chlorine combine together to form a sodium chloride molecule. Okay, so within each molecule, sodium chloride, the attraction between them is also very, very strong. Okay, it's called intermolecular forces. That is why they have very, very high boiling point. You need a lot of energy to break those bonds. Okay, you got that. Now let's go on. Basically, we have looked at this before. What is ionic bonding? Okay, we said ionic bonding. Ionic bonding involved one atom, which is normally a metal in it. Normally a metal in groups, okay? In groups 1, 2, 3, donating, okay, the electrons in its outermost cell, okay? In its outermost cell, yes? Outermost cell in it, okay? So, a non-metal in group 5, 6, and 7. Why not group 8? Because group 8, they are called stable. They are stable, yes. They are called noble gases. And some people call them group O. Some of them group 8, some people can say group O or group 8. Because all of them, they have 8 electrons in their outermost cell, okay? So they don't need any donation, they don't need any sharing, okay? Because 8 is the maximum amount of electrons in the outermost cell, except for the K cell. The K cell, the maximum amount of electrons they can take is 2 electrons. But after the K cell, the rest can take up to 8 electrons. So noble gases, all of them has 8 electrons in their outermost cell, so they are all stable, okay? They are all stable. So all these other metals and non-metals, when they give or they receive, they become noble gas configuration. Okay, they have 8 there. Like sodium, if sodium have 1 electron in the outermost cell, okay, if it gives an 8 in the L cell. If it donates it 1 electron, let's say to chlorine, chlorine has 7. So if sodium gives it 1 electron, chlorine will have 2 in it. Sorry, 8, meaning it has a noble gas configuration. Remember the word noble gas configuration. Remember that word. Okay? So what happened? That means there is 0 cell here for chlorine now, sodium now. Okay? So sodium has attended noble gas configuration. Chlorine has attended noble gas configuration. But guess what? Sodium is not now a sodium atom, but a sodium ion. And chlorine is now a chlorine ion. It has a positive of 1, this has a positive negative of 1. That's why the positive and negative, they attract each other. And that force, that attraction we call intramolecular force. If it is very, very strong, you need a lot of energy to break it. That's what we call the boiling point. Like water, the boiling point of water is how much? 100 degrees? 100 degrees in it. You'll find there are some substances or some compounds which the boiling point will be about 200 plus. Okay? I just saw one examination question here. That's how I was pointing to you guys. Yeah, it gives the boiling point of different, okay, that's density. But give, you see, boiling point of this compound is 887, looks like 7 times the boiling point of water. That means this compound is very strong ionic compound. Okay? Look at this other compound, 670 degrees Celsius. That means it must have a very strong intermolecular and extramolecular forces to break those molecules, okay? So basically, you can know that they have higher boiling point than water. Suspiciously, they form ionic compounds, okay? So you can do an RB, which is rubidium. Rubidium, I think, is in group 1, okay? Yes. Now, by looking at the boiling point, you can know X and Y. They have boiling point, melting point, boiling point less than 100 in it. Yeah. That's the temperature at which, when they are in solid state, they change into liquid state. That's the temperature. Okay? Yeah. So water, water, when it's freeze 0 degrees, it will freeze in it. 100 degrees, it will boil in it. So the same concept. All right? Why it does? So basically, ionic bonding involves one atom, normally a metal in group 1, 2, 3, donating electrons in its outermost cell to a non-metal group in group 5, 6, and 7. So the key word is donation of electrons between a metal and a non-metal. Okay? So we can say that ionic bonding is the reaction. Is the reaction. What's going on? Why all this pen? Ionic bonding, basically, ionic bonding is the reaction, okay, between a metal and a non-metal. That is the basic definition. Okay? Basically, it will be between a metal, which is a electron giver in it. Electron giver or donator. So we can say that ionic bonding involves donation of electrons as opposed to covalent bonding, which is sharing of electrons. That's the main difference. Donation and sharing is the main difference between a covalent bonding and an ionic bonding. Okay? So we know the metals are in group 1. Okay? They have group 1 because they have 1 electron in the outermost cell, isn't it? Yes. The first one is 2,1, then 2,8,1, then 2,8,8,1 in it. Then you go to group 2 in it. In it? Group 2, 2 in it. Because you must have 2 in the, no, 2 in the K? Exactly. That's why they all start with 2 in it. Okay. Now, next one will be 2,8,2 in it. Next one is 2,8,8,2. So each subsequent atom or element has one more electron cell in it. Yeah, that's right. Okay, so group 3 will be 2, 3 in it. Then next one 2, 8, 3. The next one 2, 8, 8, 3. So they can all donate electrons. But once you come to group 4, which is carbon is the best known one, carbon and silicon, they become 2, 4. 2, 8, 4. This one, they all form covalent bond because it will be difficult for them to donate all these electrons. Yes, they all form covalent bond. Once you reach here, you finish metals. Okay, non-metals. Group 5, I think first one is 2, 5 in it. And that is which one? Who knows? 2, 5, 7. Nitrogen. And the next one is 2, 8, 5. Now you go to group 6, okay, there will be 2, 6. And that is oxygen. Next one is 2, 8, 6. Then group 7, 2, 7 in it. Oxygen, then 2, 8, 7. Okay, iodine. Yeah, fluorine, yeah. Fluorine and chlorine. Now, these are the metals we have seen. They donate electrons. So when they do, they become ions. Now we are going to demonstrate that by the dot and cross. Okay? Now let's see between group 1, say sodium, group 1, and chlorine. Group 7. Okay? Group 1 and group 7 metals. Okay? What happens? Well, let me get another pen because these pens are not going, yeah? Okay. Now I have a new pen now. Okay. Because people may not be able to see the blackboard. Now we have between group 1 and group 7, okay? That is group 1 is sodium and group 2 is chlorine, and sodium atom is 281 and chlorine atom is 27 in it. Or is it 287? No, it's 287, not 27. Fluorine is 27. Yeah. Fluorine is the first one. Yeah. Now let's look at these two. Our cross and dot. Yes, cross and dot. I need another pen like the one to demonstrate this. I don't know.
I've got green.
Okay. Now let's look at it. This one is heavy, not heavy. Now let's start this one. Now we look at sodium first. Look at it exactly the way I did, because that's what the examiner is going to give you marks and will deduce you if you lose. You don't do it properly. You have to draw the sodium atom. Okay? Remember, sodium will give you 1, will give 1, and chlorine will take 1. And what did we say about the formula? Okay, the formula of the compound. When you have a compound, Y has a 2 plus and X has 3 plus, what do? The exchange valence is in it. Yeah. So for X, we'll take the valence of 3. So you need 3 of X in it. No, 3 of Y, yes. 3 of Y. Okay, and need 2 of X. Okay, so the compound is going to look like this. Y3, X2. Why? Because if you look at it, Y is 2 plus. Okay? X is 3 plus. Okay? Now, one of these, sorry. Why do I need 3 plus? You should have told me that you can't have 2 plus and 3 plus reacting because they are all metals.
Oh, yeah.
You should have told me that, yes? So it's minus metal and a non-metal in it. Ionic bonding. Okay? Now, if you look at this, 2 plus minus 3, 2 minus 3, what are you going to get?
1.
Minus?
1.
You forget your mathematics.
No.
Sign of the bigger number.
Yeah, minus 1.
Minus 1. You didn't say, but you say 1.
No, I asked minus 1.
Minus 1. Then there is one more negative in it. One more negative. Okay? So this thing, you have to find the LCM between 2 and 3, which is 6 in it. Okay? 2 into that 3 times, because what you do, 3 times, yes? And 3 into that, eh? So you need 3 of that and 2 of that. And you look at it. You get Y2 plus, okay, plus y2 plus y2 plus and plus x3 minus x3 minus. Yes? So how many positive do you have? Plus 6 in it.
6 here.
Minus how many you have here?
6.
6. How many guys? 0. So now it's stable. There is no charge. Do you understand? That's why the easiest is they exchange valences. So sodium and chloride, sodium is 1 plus, chlorine is 1 minus. When they exchange each one in it, you have sodium, the compound will look like this, sodium, chloride in it. Yeah. One positive, one negative, they cancel each other, 0. So you look at sodium, 1 electron in the outermost cell, chlorine, 7 electrons in the outermost cell. How do we apply the dot and cross? Okay, the dot and cross diagram. Now when you come down here, sodium will look like this. If you want, you saw only the outermost cell in it. Okay. Two, 8, and 1. That is sodium atom in it. And you have to write the sodium atom. You must do exactly like that. Mustafa, can you pay attention, please? Because we have to finish ionic bonding today. Now chlorine, we say chlorine. Okay, chlorine, Cl, then we have 7. Now, you look at them. So what's happening is there will be donation of this one to that in it. Oh, red pen. Where is the green one? Are you okay? So this electron will be donated in it. Remember, it's donation in it. You don't put this in the, maybe I'm solving the connection. I'm just putting there for it for demonstration purposes, okay? But this electron is donated here. Then you do your arrow, okay? We drew the 2 again. 1, 2. 1, 2, 3, okay? Now what will happen is, this is our sodium, and this is our chlorine, yes? Sodium will be left with 2 here, then it's 7, it's 8 in the, now the outermost cell. The other cell will disappear, because there's no electron there to disappear. Okay? Now you have to show aside, demonstrate here. This is no more a sodium atom, but it is a sodium ion. So you put your plus here, I mean it is positive. This one is chlorine, but a different chlorine now. It is a chlorine ion, yes? So it will be like this, 2, 8, then 2, and then, okay, let's say, okay, so that means this chlorine, this electron is donated to chlorine, and you have a chlorine ion. This is negative. So look at this. When you do this dot and cross, this is called a dot and cross diagram of atomic ionic bonding, yes? So you have to show exactly like this. Huh, Ali? You have to show that this is a sodium atom, chlorine atom, okay, chlorine atom. Sodium denote 1 electron to chlorine, okay, and then it becomes sodium ion, one positive because it gives out 1 electron, and then chlorine ion, 1 negative because it receives 1 1 electron, yes? Now if you look at why this is positive, why?
It's because the proton have a positive charge.
Because this is 11 electron there in it. And the number of electrons is equal to the number of protons in it. So in here, if you look at here, there are 11 protons in it. 11 protons in it.
Yeah.
And electron is equal to 11 in it. So therefore, this is 11 positive and 11 negative in it. Same thing applies chlorine. We don't need to do that. But look at here. Let's look at this. Here, proton is equal to 11 because protons don't take part in the reaction in it. But electrons, curiously, is 10 minus. So basically it become 1 minus. That's why it's 1. Yes. So you can apply the same thing. Chlorine, yes? Yes. Same thing. Number of electrons, number of protons, it will have 1 minus. Okay? Now we said we are going to look at group 1 and group 7. How much? We can quickly, yeah? Now let's look at group 1 and group 6. Okay? Group 1 and group 6.
They have to be more.
And oxygen. Okay? Sodium and oxygen. Can you put your attention here, please? We look at sodium and oxygen, okay? Again, sodium is 281, oxygen is 26. Meaning, oxygen needs 2 electrons in its outermost shell to make it 8, to get a noble gas configuration, yes? Noble gas configuration in it. Yes. So how do you demonstrate that in a cross and dot diagram, okay? Do you guys see? When sodium loses 1 electron, it becomes 2,8 in it. Chlorine receives 2 electrons, become 2,7. This is not fully, doesn't have full. Okay? Now you need another chlorine in it. 281, it gives it electron, become 2,8 in it. And this become now 2,8 in it. Yes. Now it has a noble gas configuration. So therefore, you need 1 sodium and another sodium. So basically, our theory that the exchange valencies, okay, is correct. The exchange valence in it. You need 2 sodium because this is 2 plus, okay? You need 2 sodium and you need 1 oxygen in it. Oh, so the compound look like this, N2O. You get it? And that is demonstrated here because it will left with 1 more negative, okay? Now let's draw the dot cross and dot line quickly before we get to 30 minutes. If not, it's difficult to download. Okay? Now let's draw our this one you have to be careful when you're drawing it, yes? Because we have 2 sodium in it. So we have to put oxygen in the middle. Okay? We put our Mr. Sodium here. Okay? 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 No. Okay. Now let's put our stuff inside. Now this is sodium. Sodium is 2, 8, 1. Okay. Now oxygen is 2, 6. Okay. Now our sodium again. You get it? So this is a sodium atom. This is a chlorine atom, sorry, oxygen atom. Okay? And this is a sodium atom. Now what will happen is, oh, I have a red pen and write. This sodium we donate electron here. This one we donate electron here. Let's finish this quickly. Okay. Now if it does, okay, sodium will be left with 2,8 in it. Yes. 2,8. Chlorine, Mr. Chlorine will be left with one of that from this chlorine, one from this the other chlorine.
Yeah.
Yes.
And just 2. Oh, you missed one from there.
Okay. So 8. What's the matter? Okay. So this will be between, because it does electron, it will be minus. This will be 2 minus, and this will be minus 1 in it. Or only minus. If you want, you can put minus 1, you can put only minus because it's 1. Okay, it's 1. So yeah, sodium plus, yeah, sorry. Okay, oxygen 2 minus and sodium plus. You have to show all this in the diagram. Do you see? So basically it is donation of electrons in it. Yes. And you have to show plus here, and it give, that's what it gives to, isn't it? Yes. And you have to show the arrow here, that this electron is coming from here to here. I think I need to get another pen. It's coming from here to here. This is coming from here to here, isn't it? Yeah. Yes. And this was our dot. Okay? You see, this is between group 1 and group 6. Yeah? So the next one we have to do group 2 and group 7. Group 2 and group 7. You can do your own practice, yes? Okay? Between group 3 and group 7. But the same pattern. Okay? So I have to show you what happened actually. Okay? So this is called the dot and cross diagram. In the exam, they can ask you to draw the dot and cross diagram between the reaction between sodium and oxygen. And that is very important that you know. Okay? Okay, we are up to 30 minutes, so I will end here. Then we'll continue on looking at the order, the because of this positive and negative attraction. This is called the intramolecular. This is called electrostatic forces in it, but it's called intramolecule because this is inside the molecule, the positive and negative. Yes, okay, intramolecular forces. Okay. Now, because when you have a compound of sodium chloride or sodium oxide, okay, you have a lot of atoms of sodium, molecules of sodium chloride, yes, sodium oxide, yes, and they'll be in a giant structure, yes, with 2 sodium positive and 1, yes. The forces between this molecule is called that means, look at it here, oxygen with sodium and sodium, yes. Another oxygen with sodium and sodium in it. So the attraction between these is called intermolecular forces, yes. Molecular forces. And these 2 forces are responsible for the higher boiling point and higher melting point and higher boiling point, and even the conduction of electricity. So we're going to look at this, yes. Okay. The examiner wanted to make mention of that they are responsible for the higher boiling point and higher melting point. Okay. Okay. Now we can end here. We could do the next. This one was 10:1. The next one will be 10:2. Okay. Lesson 10:2. Okay. Lesson. Okay. Subhanallah bihamdi subhanallah lazim. Astaghfirullah ila illa anta astaghfiruka wa atubu ilayk. Okay.